Hello everyone, welcome back to my channel. I hope everyone is doing great. My name is Raviteja. Let's solve Leetcode problem 416 partition equal subset sum. Given an integer array nums, return true if you can partition the array into two subsets such that the sum of elements in both the subsets is equal, or return false. Okay, you have to divide this given array into two subsets. Okay, such that the elements in the sum of elements in each subset should be equal. Okay, so one valid combination is basically you can divide the array 1, 5, 11 and 5 into 1 comma 5 comma 5, and this is one subset, and you can also have another subset of 11. Okay, the sum of elements here is 11 and sum of elements here is also 11. Okay, this way you can break down the given array into two subsets. If you take this particular array, there is no way you can break down. Okay, if you keenly observe, we are breaking down the elements into two subsets. Now if you want to break into two parts, that means the given array should contain the sum of elements as even. Then only you can break down into two subsets. The first check is if the overall sum, if it turns out to be even, then only it is possible. If it is odd, then straight away it is not breakable. If you take this example, 5 plus 3 is 8, 8 plus 2 is 10, 10 plus 1 is 11. Okay, 11 cannot be broken down into two parts, so that is the reason the answer to this is false. Okay, now that we got to know, first is to identify the sum and check whether the sum is even or odd. Okay, if it is odd, then straight away we will return false. If it is even, that means answer is possible. Now if it is even, can we boil down the problem statement into generate a subset whose sum of elements is equal to the overall sum divided by 2. If we were able to get a subset from the given array, then automatically if the subset has sum as x, then automatically the other subset will have sum as sum minus x. Correct? Now what should be the sum of the first subset? If sum of the first subset is sum by 2, then automatically the second subset will also have sum by 2. Okay, where sum is the overall sum. This way we can automatically break down the given array into two subsets. Right now the problem statement boils down to, can we have a subset with sum equal to the overall sum divided by 2. If there exists a subset whose sum is equal to overall sum by 2, then automatically I can break the overall array into two subsets. Now let's check whether the given array 1, 5, 11 and 5, is there any subset whose sum is equal to 11 or not? Okay, now what does a subset is? Subset is basically a group of elements from the initial array. So one subset is basically empty, considering no elements from the given array. Another subset is 1, another subset is 5, where I am only considering one element. Another subset is 11, another subset is 5, another subset is 1 comma 5, another subset is 5 comma 11, 11 comma 5, and so on and so forth. There are so many subsets. Okay, so I was saying at any given point, a given number have two options, either to be part of a subset or not to be part of a subset, right? So can be part of the subset or it cannot be part of a subset. If I choose to have 1 as part of my subset, then I have to form a sum of 11 minus 1 from the remaining elements. If I choose 1 not to be as part of my subset, then using rest of the numbers I have to form a sum of 11, right? Now again here I have two options. Either I can have 5 as my part of my subset or not to be part of a subset. If I choose to have 5 as a part of my subset, using rest of my elements I have to form a sum of 10 minus 5. If I choose not to be part of a subset, then using rest of the elements I have to form a sum of 10. Again here we can also have the similar kind. If I choose to have 5 as a part of my subset, then using rest of the elements I have to form a sum of 11 minus 5. And if I don't choose to have 5 as my subset, then I have to form using rest of the elements sum of 11, and this will keep on go, right? So if you see, we will be reaching a point where we will be forming a sum is equal to 0. Okay, let's take this particular tree. Okay, here I have two options: include 11 as part of my subset and include not 11 as part of. If you include 11 as my part of my subset, then using 5 I have to form a sum of 11 minus 11, and using 5 I have to form a sum of 11, right? So here you can see I have to form a sum of 0. Sum of 0 is possible by including no elements from my array. So this is a valid subset, right? So if you see, by including only 11, I can form a subset of some subset whose sum is basically 11. Okay. So I hope you are understanding what I'm trying to say. Okay, given, let's try to formalize whatever I have explained so far using a function. Okay, let's say I have a function f which will take an index I and a sum s. Okay, and tell me whether the sum s can be formed with the elements from I till end. Okay, now at any given index, as I mentioned, we have two options: either to include or not to include. If I choose to include, that means I have to form, using rest of the elements, sum minus, right, sum minus nums of I, right? That is what we have done. If I include it, then sum minus the value at ith index. Or I have another option: I can get answer from this subtree, or I can get answer from this subtree. Or f of, if I don't include it, then I have to form, using rest of the elements, sum of s, right? Now this is the recurrence relation, right? Now there will be a point where you have noticed that the sum is equal to 0. That means I have to return true whenever my sum is equal to 0. Now if you see here, at this point again there will be a moment where there are no elements in the array, but still you have to form a sum. Let's here, if you include it and if you don't include it, then there will be, if you include it, then I have to, using no elements, I have to form a sum of 11 minus 5. If I don't include it, using no elements, I have to form a sum of 11, right? So when there are no elements, how can I form a sum of 11, right? That is not possible. So if there are no elements or the sum itself is less than 0, then I cannot form answer. So in this particular scenario I will be returning false, right? So given a function, I have its recurrence relation, I have its base cases. Okay, now let's try to code it. You will also notice there are certain states which will be overlapping. Okay, here it is not visible, but definitely there will be certain states which will overlapping, because I is going from 0 till n minus 1 and s is also going from 0 to s, right? I mean, here it is going from the vice versa, okay? It is going from 0 to n minus 1 and sum is going from sum till 0, right? So there will be definitely a point where some of the states will be overlapping. So we have to use dynamic programming over here. So the whatever states which were already calculated, answers to those states has to be stored in a place and then reutilize it, right? We don't have to recompute it again and again. Let me go to the code and show you the bottom up approach. Okay, so as I mentioned, first we will be calculating the overall sum of the elements, right? Here initially I just defined nums and n as part of my class variables, okay, so that I can be access it from any of my functions in this class. So as part of my first step, right, as part of my first step, I have to calculate the sum, overall sum. So here I'm calculating the overall sum of the elements in the array. So excuse me. Now if the sum is odd, that means I cannot partition it into two halves. If sum is even, that means have to divide it by 2 and then get the answer for the given sum. So in the top down approach, as I mentioned, I will be having a function which will tell me the answer given for I and s. So the same thing I have done over here. I have written a function called is possible, which will take an index I and sum and tell me whether, by considering elements from I till end, whether the sum is possible or not. Okay, the base case is basically if sum itself is 0, then my answer will be true, right? That is what I have mentioned. If any one of the index, if there are no elements to consider but still sum is some positive sum we have to form, then this we have to return false. Or if the sum itself is negative, that means we cannot form answer, the in this case also will be returning false. Or else I have to basically get the answer from the remaining two options, either to consider the current element or to not to consider the current element. If I consider the current element, then sum will be reduced by nums of I minus nums of I, and using the rest of the elements from I plus 1 till end, I have to get the answer. If I don't consider using rest of the elements from I plus 1 till end, I have to get a sum. As I mentioned, there will be certain states which will be overlapping, so I just define a DP array, DP2D array of boolean type, and if the answer to a particular state is already calculated, then I will be returning the answer, or else I will be recomputing the answer, compute the answer and store it in my DP or cache. Okay, now I just defined a function called top down, where I'm just instantiating my DPR and calling this function from 0 till all the way to the sum, where sum is basically the overall sum divided by 2. Using this approach also, all the test cases will be passed and it will be a pretty efficient solution. But this can also be solved using bottom up approach. Okay, if you observe the top down approach, the value of I is going from 0 till n minus 1, and the value of sum is going from sum till 0. So I has to go from, I is going from 0 to n minus 1. So when in the bottom up approach, we will be filling it in the opposite direction. So it is going from 0 to n minus 1. That means in bottom up approach, it has to come from n minus 1 to 0. Okay, again sum is going from sum till 0. In the bottom up approach, we will be filling in the opposite direction, so it will go from 0 to sum, right? Now in the so in general we need a 2D array of size n plus 1 and sum plus 1, because my final answer will be lying in DP of 0 and sum. If there are no elements to consider, or if a sum of any sum of 0 can be formed using all the elements, right? So by default, by considering elements from 0 till all the way till the end, or from first index till all the way till the end, sum of 0 is always be possible. So I have written this particular value as true, and for the rest of the cases, the answer to my current state will come from by skipping the current element. This is for basically skipping, not to choose the ith element as part of my sum. If I choose to consider ith element as part of my sum, then I have to get the answer for sum minus nums of 5, right? So that is what here I am doing. This is a similar state which we have over here. We have to get the answer using rest of the elements for sum minus nums of 5, which is sum minus nums of 5. So this is transformed into this, and this is transformed into this. And since we are going in the bottom up approach, we have to first check whether nums of I is less than or equal to sum, because here we have handled the negative cases, but here we have already predefined that the sums are sum and the elements are from 0 to n and 0 to sum. So we are having this check so that it will be within the bounds. Okay, and then my answer will lie in dp of 0 comma sum. And if you analyze the time complexity over here, it is order of n into sum, and the space complexity is order of n into sum, which is same. Okay, this can further be reduced into order of n in terms of space complexity. I will give you that as a homework to you. If you're following my DP series, you should be able to convert this solution into order of sum itself instead of order of n times sum. This can be converted into order of sum. I will give you this as a homework to you, and feel free to provide the solution in the comment section. I will be reviewing it. That's all about this problem. If you like the explanation, hit the like button and hit the subscribe button. I will be posting the solution in multiple languages. Feel free to check it out if you are coming from other than Java language. Okay, thank you.